I'll be getting started here in just a minute. Just tweeting this out real quick. All right, what's up, everyone? Get started here in just a minute. Going to be going over basically setting up, getting your environment set up to start building CLN plugins. We're not really going to get into the plugin stuff today. We're just going to, get Bitcoin D running on your computer, get Core Lightning running on your computer. We're just going to do everything locally, so it should be we're gonna build Core Lightning from source, so hopefully that's not too difficult. But I find just having everything running locally on my computer is easier than trying to get it all spun up in Docker containers or using other tools like that. So if you have, I'm gonna be doing everything on Ubuntu. I just am running a virtual machine here where I have fresh install of it. So everything should be, I don't have any dependencies installed yet. So I'm hopefully my goal is to kind of like make this accessible to anyone, but of course every operating system is going to be different. So if you guys have any trouble, drop it in the chat. Um, Otherwise, you should be able to generally follow along. All right, let's see. Got 4 people on Twitch. You guys, someone try and drop something in the chat just so I can see if that's working. Um, and then we'll just get right into it. All right, well, I don't see anything in the chat, so I'm gonna assume everything is working. But all right, I'm gonna get started now. So here I've got the GitHub repository open where I've basically gone through and put all the instructions that you'll need to do this on your own. So I'm basically just gonna go through this. So this is a subdirectory inside of this developing CLN plugins repository. And here I've just kind of gone through, laid out a little bit. One of my motivations for doing this workshop is that building CLN plugins is what felt like one of my first real Bitcoin projects. I had been trying to build Bitcoin projects before, trying to figure out what it meant to be a Bitcoin developer. But it wasn't until I built a Core Lightning plugin that it really felt like I was actually building something on Bitcoin. we're going to be doing, this is the environment setup today, and then in a couple weeks, I'm going to talk about just the architecture of Core Lightning plugins, how they work. Brief overview is basically, uh, it's just custom functionality that you can add to your node so that you can write any code you want as a plugin, and then you can add CLI commands to your Lightning node. We don't really need much, just a computer. Like I said, I'm just running this on a fresh install of Ubuntu. Here's a few links, not very important for today, but if you want to read up for our next one where we start talking about plugins, these are mostly from the Core Lightning docs, but also here is Bitcoin RPC commands, and I think I'm going to go over a few of those today. So I'm still working on this, but these are going to be the other two workshops, but right now we have the environment set up here. All right, so basically we're going to be, in order to start developing plugins, we need to have our environment such that we can simulate the Lightning Network. So we're going to need some nodes, Bitcoin node, and some Lightning nodes. So we're going to just use the snap package for Bitcoin Core, just because it's easy to install. But I think that's fine for just when you're developing things. But if you're going to be running a node, I'd recommend building Bitcoin Core from source if that's like going to be the node that you're sending and receiving transactions from. So I already went ahead and installed snapd, which is basically, it's just like it's a package manager. So it helps, and there's in Bitcoin Core is on there. So we can go and install Bitcoin Core. So you can just copy everything that I have in this README here, and it should get you going. But I'm gonna try to kind of go through each of the steps so that you know what's going on. So I already did this. I already installed snapd, and now we're installing Bitcoin Core. So you could also go to the Bitcoin repository. I think it's Bitcoin/Bitcoin, and build it from source there. But this is just someone already went on Snap and created this whole thing. So all we have to do is run this command in Bitcoin Core. Will get installed and built, and then we can start it and start to configure it and connect to it with our Lightning nodes. So while that's going, we will talk a little bit about installing CLN. So we're gonna basically these are all the dependencies that we'll need, just different libraries that are required for building it. And then here we'll get the repository itself. And so if we go here, this is where I took actually pretty much all these instructions, is from this repository and to installation. So here there's kind of a bunch of different install options, but I guess here there's 4 supported install options. You can get a precompiled binary, use a Docker image, or compile from source. And so that's what we're doing. We already got Bitcoin D installed over there, it looks like. So here is basically the instructions to build on Ubuntu. I kind of changed them slightly, but this should be, if you have any trouble, try consulting these docs first, because there might be some more information in here. So like I said, we're using snapd to install Bitcoin, and then now we've got Bitcoin Core installed. So if we jump back over here, we are going to run, where'd it go? This command real quick, which actually don't know what it's doing, but in the CLN docs, they put Snap does some weird things with binary names. You want to add a link to them so everything works as expected. So I guess this is just linking. This is making it so that we can run this command to start Bitcoin D. So there I see Bitcoin started up. And you can see here that it's opening the database in home/goodenough.bitcoin/regtest. And that's because I used the regtest flag. So let's see, we should probably start installing our dependencies here. I'm just going to copy this whole thing. And so we're updating apt, which is the like main Ubuntu package manager. So you don't need to install that. And then here we're using the install-y flag, and that should that'll make it so that everything just installs and we don't have to say yes to it. It looks like there was some sort of error, unable to locate certain packages. See, I wonder if this comment is causing issues. Let's see. Sorry, I'm going to delete this real quick too. And if you put this backslash here, that will just like, it's still the same line, same command, but it just helps organize it a little bit. Okay, so for some reason this isn't working. Tested this all out before, but that's how things go. Okay, so I think it's just the way that I made this that we're copying. I'm not sure what the issue is there, but looks like it's installing AutoConf now, so I'm just going to copy the rest of these packages in. And I'm actually going to leave one out so that you can see. So now we have to install everything else. So these are all going to be, this is on Ubuntu, like I said, but everything's going to be different on different Linux distributions, or if you're on Mac, these libraries might have different names. So we can try to go through some of that if we get some packages that aren't found, but I'll show you. Because I don't know if you saw, I deleted this one package, so it won't install that. So when we start trying to build CLN, it should give us, we should start to see an error that this package is missing. And then usually with these things, when you try and build them, there's checks in place that check to make sure you have all the dependencies. And if you don't, then you'll get an error, and then you can usually copy and paste that error into Google or into ChatGPT, and it'll help you find the right library, figure out, some of them have different, like, are on different package managers, so it's just kind of a matter of finding which library you need and how you need to install it. So while this is going through all of the dependencies, we can start to mess around with Bitcoin, because this is going to take a little bit to install everything. So let's see, I thought I opened up a new terminal here. All right, so I already showed how to start Bitcoin, And when you use the Snap Package Manager, at first it won't show, it won't create the Bitcoin directory. So you just have to start it once, like I already did, and then what you should see, if you list all of the directories in your home directory, you should see this .bitcoin file, and it should be just created in your home directory, but you can just start it up really quick to see. I just started it and stopped it, and you can see everything is starting in this home/goodenough/.bitcoin, and that is the directory that got created for us. Again, you can see it here, .bitcoin. We're going to go in there, and in here, there's not much. We've got the reg chest directory and our wallets. I'm going to take a pause on Bitcoin for a second because it looks like our dependencies are done installing. So now we are just going to clone. This is cloning the Lightning repository from the Elements project and then just changing into that directory. So that should just go by real quick. And maybe you don't have Git installed. And if you don't, you'll try and run the Git command and it will fail. So then you'll have to install Git. So that is installed there, or we've cloned the repository. And now we're in, you can see goodenough/lightning. So now we're going to check out the release branch. This is just like a stable branch, and you might get a scary message that says you're a detached head. So you should be able to say git checkout probably master. And so now we're back to the master branch, but we want to check out this tag. Make sure that worked. So now you can see this is the entire Lightning repository cloned. And in order to make sure that everything, because we're going to install a bunch of Python packages, in order to make sure all of that doesn't break if you have Python installed globally on your machine, some of these packages might mess some stuff up on your local machine. So we're just gonna, if you install Python 3-virtual env, then this will allow us to, basically, we're creating a virtual development environment where everything that we install on Python will only exist in that virtual environment. And so we're using that package manager to install that. And then now we have the virtual env command. And so we can say virtual env vnv. And so this will create a virtual environment within this Lightning directory. So if we create this, well, let's see. Let's go like ls. It should be .vnv. There's nothing. And now if we do this, we need to do virtual env. See, now you can see it created this virtual environment that exists at home goodenough/lightning/vnv. So I actually did that wrong, but this should be, now you can see we have the vnv file. And now just taking this from the README, we're going to say vnv. So this is what this is doing, is this is running a script, and all of the environment outputs are getting saved to this instance of our terminal. So running source to do that, and then this script is the activate script that lives. Well, let's look at it. LSVNV. You can see we have the binary, the lib, and the config. If we look at the bin, then we should have this activate script. So we're going to run that. And now you can see I have this little VNV thing. So now we know we're in a virtual environment. So let's see, we've activated VNV. And now we're going to install the Python dependencies. So these will all be installed within this virtual environment. We're first installing and upgrading pip, and using pip to install the Mako library. And because I used here sudo pip3 install Mako, gave me this warning: running pip as the root user can result in broken permissions. If you want to try doing this without sudo, you can try, but that's the only way that I could actually. It seems like it installs properly, but then once you get to later steps, it seems to not work. So now you can see we have a. Let's see, grep. So we have this configure script. I don't know if it's even really worth looking at. So we're just going to run it. Run this configure script, and this will basically set CLN up so that then we can build it. So let's see if I linked to the CLN docs on that script, and so basically you'll see a bunch of these flags that you can pass. And so this is just basically like, how do you want CLN to be built? So you can go through here and add customizations that you want. But it looks like sometimes it's hard to tell. You get all of this output to your terminal, and it's hard to tell if it actually did it properly. Usually the errors will be down at the bottom, and so it looks like we're all good there. So we've run configure, and now we can run make. And see, this is where we get an error. No module named Mako. So this is, I keep having this issue whenever I build, and this is just one of those things that you have to go and figure out. So let's see. Let's try this one more time. pip3 install Mako. Nope. Mako. And now we could try running make again. We still get that error. All right, so interesting. I use sudo make, and now seems to be working. I honestly wasn't. I was, when I was testing this out, I was trying. I followed the CLN install docs, and they just say pip3 install Mako, and that wasn't working. And I just kind of tried a bunch of things, and this is what ended up working. It's kind of nice. I'm doing this all in a well, one, we're using pip in our Python virtual environment to install, so you don't have to worry too much about just like downloading random packages. But then I'm also doing this on a virtual machine, so it's kind of nice because on my main desktop I don't want to just blindly be installing things, but this can be kind of a good way to just test things out, and then once you kind of think you got it and it's what you want to install, then you can go onto your main desktop and build it there. So sometimes it's kind of nice to watch, like you'll see see weird things. Like this looks like it's just a warning. Um, but it can sometimes it won't work and you'll have a hard time figuring out why. So this is going, and I'm expecting it to fail because I didn't install that last package, but we'll see how far it gets. And this should, as far as I understand it, this should all go, and then it's doing a bunch of work right now, but the work will already be done, so once it fails, then it should get back to this same point. So I'm not sure how long that's going to go, so we can go back to talking about Bitcoin D. So remember, we got into this .bitcoin directory, and this is where everything lives for Bitcoin Core. So we have that regtest folder and wallets. Let's see what's in regtest. We got a bunch of stuff. We got blocks. We got our chain state, our mempool, peers, wallets. So this is like kind of everything that Bitcoin needs, all the data that Bitcoin needs. And you'll notice we have just this regtest directory, but if we just start Bitcoin without the regtest flag, it will start in just home/goodenough/.bitcoin, and it'll start, now it's starting to synchronize with the blockchain. It's getting all the block headers, and so we can just do this for a second, but we're going to do everything in regtest, so I'm going to stop that. So shut down. Let's see, it looks like we're back over here. So here you can see cannot find -lgmp, no such file or directory. It's kind of hard, like what does that mean? It's not totally clear that that means we didn't install this package, but I almost guarantee you if you copied this into ChatGPT, it would tell you to install that package. So we can just install that really quick. Sorry, I'm jumping back and forth between these two, building Lightning and going over Bitcoin D, but no point in watching it download. So it looks like it's installed, and so we can try running make again, and it should go back through and hopefully not fail this time. Okay, so remember we were checking out Bitcoin, and at first we just had that regtest and wallets directory in here, but now that we've started it without the regtest flag, now we've kind of got all this other stuff going on, which is everything that's in the regtest folder, but this is all for mainnet. So just, I think, kind of interesting that it gets created only after you start Bitcoin on that network. But because right now when you run Bitcoin D, it will start it on mainnet. You can tell because the directory that it's starting is not in the regtest directory. So what we want to do is create a bitcoin.conf file. So you'll see there is no bitcoin.conf. So what we do is Nano is just a text editor that comes with Ubuntu, and if you just say this, it will create a file with this name. So going in here, and the only thing that we're going to add right now is regtest equals 1. So now you can see we should have a bitcoin.conf, and we can now start Bitcoin D. And let's see. Now, because I set that regtest equals 1, basically regtest is true, we're starting in the regtest directory. And one more thing that we could do if we want is add daemon, I think that's how you spell it, equals 1. And now when you start Bitcoin D, it'll just say Bitcoin Core starting. Also, if you want to kind of use the command line flag, I think you can use dash daemon, and it will, if you don't add that to your conf, this will do the same thing, but Bitcoin is already running. So now we have Bitcoin D running. And what that means is now we can use Bitcoin CLI. CLI is command line interface, I think. So you can see we've got some RPC commands here. These are all just, or like, these aren't the RPC commands. These are just different flags that you can add to Bitcoin CLI. And so you could do like something like Bitcoin CLI dash get info, and you'll get a little bit of information about the chain here, where we have 0 blocks, 0 headers, 100% verified. This is the difficulty of our reg test network. And so reg test, if you don't know, is just it's just a test environment where Bitcoin is running locally, and so we're creating a blockchain on our own machine and not connecting to anyone else's blockchain. And so this gives us a lot more control of Bitcoin in our wallet and just creating blocks and moving the network forwards. So it's quite handy for development purposes. So we went through this, the Bitcoin config. Let's see, I guess, oh, here is the Bitcoin RPC. So some cool commands we can do: get blockchain info. It's has a similar output to get info, but it gives you more. It gives you, because this is for the RPC, it's a JSON RPC interface, so all of the outputs are going to be in JSON. And we're running these commands just from the command line, but the RPC interface allows for you to connect to your node and run these commands pretty much from any program. So hold on Bitcoin for a second. We're back over to Lightning. It looks like our make command was a success, and now we can run make install, which should be the final command. Is this an error? Doesn't look like that was an error. Happened faster than I expected. But how I'll know that it works is we should be able to run Lightning D. Bam. Works. So we were talking about the command line interface on Bitcoin. And now we've got Lightning installed. So this is as far as I wanted to get. Now we have both Bitcoin and Lightning installed. So let's go over just a little bit more. I haven't added it to the README here. Everything after here I still need to work on in the README, but we can go through some more Bitcoin CLI commands, some Lightning CLI commands, and then we'll go through this script that comes in the Lightning repository. It should be contrib start up reg test, and that should just, we don't need to go through all of it, but I think there's some nice comments at the top. It's a short script to start up some local nodes with Bitcoin D all running on reg test. So this does require that you have Bitcoin D installed, which we already did. And it says here, it makes things easier to test out by hand. And so this will basically allow us to spin up as many Lightning nodes that we want connected to our Bitcoin D backend, all on reg test. So everything is locally done and you don't have to worry about losing any actual Bitcoin or anything like that. So let's see, where are we? We can go through the Bitcoin CLI commands for just a second to start to kind of, there's a few things that we're going to need in order to simulate a Lightning network and start building plugins. So one thing that we're going to need is some Bitcoin to test with. And so you could say list wallets, we have no wallets. So we can say create wallet, and then the name of the wallet. If you spell things wrong, it doesn't work. And you can see this command is in these RPC docs under wallet RPCs create wallet. And here you'll see this is the command, and then this is a required argument. You can see here argument 1, it's a string and it's required, and then everything else is optional. And so it's kind of fun to go on reg test and kind of start to mess around with these things. If you disable private keys when you create the wallet, your wallet won't be created with a key and you won't be able to actually spend anything. It's just only watch only. You could add a passphrase if you want. You could make it so it loads on startup. We're just going to start with basic wallet. And so now if you run list wallets, you'll see we have this plugin dev wallet. So now what else do we want to know? We want to maybe get our balance. Let's see, there's a question. Would it not be easier if we Dockerize both Bitcoin and Lightning node setups and simply run the containers while mounting workspaces as local volumes? This way we won't have to worry about installing all the dependencies and other requirements. Yes, I think that this would be simpler. Thought it was interesting to build CLN from source, but also I think it's nice to kind of see all the nodes on your computer, and it's easier to get command line access. That way you're not like because now we have the Bitcoin CLI command here, and we don't need to like use docker exec to get into the container or anything. But this is just one way of doing it. I'm sure there's a ton of ways. There is a tool called Polar, which I'm sure some of you guys have seen. That is nice for setting up a Lightning network, but it's not the best for plugin development because the plugin itself needs to be built into the image. So you could mount it as a local volume and then restart it from there. But this is the way that I like to do it. So if you can do it however you want. The basic requirement is that you have Bitcoin D running and Lightning D running. So let's see, where were we? We were gonna get the balance. Right now we have 0. So how do you get Bitcoin? You have to mine blocks. So there should be the command in here, I think it's generate to address. Mining RPCs. Well, so let's see. We can do this. First, we'll need to get new address. So this is an address connected to our wallet, and I think the command is generate to address. And then I think we want to, let's just start with one block. Okay, so now we can check out our chain state. Now you'll see we have one block because we just used that command to mine one block. But interestingly, our balance is still 0. We can check here, our balance is still 0. But we just generated a block to that address. So the reason for that is that coin-based transactions, which is the Bitcoin that gets mined, is not valid until 100 blocks have passed. So what we'll need to do is, so we just generated one block to that address, but now we can use this generate command, and let's see if 99 will do it. So now we're generating 99 blocks. Takes a little while. We gotta put in some proof of work here. You can see this block hash is not very exciting. It's not, doesn't have all those leading zeros. So we're gonna need to get our wallet funded, our Bitcoin wallet funded. And then what we're gonna need to do is start up our Lightning nodes and get their wallets funded. So this is taking a minute. Usually it doesn't take this long. So I think we should see in here, generate command. Oh, okay. So it looks like it just didn't give us an output, but we do have 100 blocks. Our balance is still 0, so I think we need to mine just one more block. And now our balance is 50, because remember we're only at 100 blocks. The first halving hasn't happened yet, so the block reward is still 50 Bitcoin. So now our Bitcoin wallet has 50 Bitcoin in it, but our Lightning wallet doesn't have any Bitcoin in it. We haven't even started our Lightning nodes yet. So we should do that. So that contrib script is quite nice. We can say source contrib / startup reg test. So this will just kind of, this creates some functions that we can call. Let's see, this is the Lightning directory that everything is running from. We can use start ln with the number of nodes that we want to do. I'm pretty sure if you don't do any, it defaults to 2 nodes. This will connect 2 nodes, which is just like making that peer-to-peer connection, but they haven't opened a channel yet. And then this fund nodes will fund them all and send some Bitcoin to their wallets. But that's what I meant by funding. And then connect them all with channels. So I think we're going to do that all manually. So what we can do first, let's just start with 2 nodes. So this gave us an error. Wallet file verification failed to load database path. So we don't have this wallets slash default path does not exist. So that's because I created this wallet with the name Plebdev. So we're gonna do unload wallet plugin dev, and then create wallet default. So this will create us this default wallet, and we can try. Let's see if L1 CLI is running. So you can see it gave us these. It created these aliases for us. We're running two nodes. We have L1 CLI and L2 CLI, and also BT CLI. So here you can verify that Lightning 1 is running, and also that Lightning 2 is running. And you'll see both of these are in the temp directory. So if we list that, let's see, what is the, oh yeah, L1. We can see here L1 reg test and L2 reg test, and just to see what's in those, just a little bit of information or config stuff. It's kind of similar to the .bitcoin file where we get this reg test folder, and this is something that we're going to want to pay attention to for the future. This Lightning RPC, this is where we're going to target all of our RPC commands when we're building the plugin. So now we have these two nodes running, but let's see. I didn't spec all this out, so just shooting from the hip here, but I think we can figure this out. We're at block height 101. We don't have any peers, and it doesn't. Let's see. We need to figure out how much Bitcoin we have, but we don't have any. So we can just say new adder. So Lightning CLI 1 now we can send to this address. And so we'll use Bitcoin CLI send to address. And send to address is here. It takes an address, so copy that in, and then the amount that we want to send. So I think we want to send 2 Bitcoin, and fallback fee is enabled. So this, I think we need to say, well, we need to set the fee. We could set the fee rate. See if there's an example in here. So here, send 0.5 Bitcoin with a fee rate of 25 sats per VByte. Fee rate equals 0.5. Address equals that. Amount equals 2. Fee rate is going to be 25. Let's see if that works. Maybe we need quotes around here. It's because we need this named flag on Bitcoin CLI because we're we're explicitly naming the parameters. Insufficient funds. And now that is because we created a new wallet. I forgot about that. We created this new wallet where if we say get info, our balance is 0 now, and that's because it's a different wallet, different keys. So we're gonna need to do the same thing to get some funds in our Bitcoin CLI. Bitcoin CLI generate to address. We need the amount 101, and now that is going to load some funds, mine some blocks to our Bitcoin node. Let's see. Blocks 197, so it didn't quite finish mining all those blocks. I just got impatient. We're at 197, so I'll do 5 more blocks. And now our balance is 300 Bitcoin because we mined all of those to that address, and now every single block we're gonna get. We mined like 100 or 102 blocks to that address, so now we have whatever 500 and 504 5004 Bitcoin, but they all need to be confirmed first. So you'll see if we generate one more block, not even to our name, but we're just generating one more block, adding it to the chain, then our balance is now 350. So now we should be able to run this command again, send to address. Hope that works. So now you can see this is the transaction ID. And let's see, I don't remember, did we do that to L1? So L1 CLI list funds, I think. We have 0 outputs. So that's just because we need to generate some blocks so that that transaction that we made can get mined in. And maybe we need more blocks. Well, we can try this one more time. Or there might be a different command that we want to use. So you can look up all the Lightning CLI commands at docs.corelightning.org/reference. So we could say these are the Bitcoin, what do you call it? Bitcoin bookkeeper. So maybe we can use this list balances. BKPR-list balances. Balance MSAT. Here we go. So now we have a lot of millisatoshis. We should have 200 million satoshis to Bitcoin. So now we're able to, this is in the Lightning CLI wallet, on our Lightning nodes wallet. L1 has 2 Bitcoin. And so now we can open a channel to L2. And so first what we need to do is connect to L2. And so here is the connect RPC command. It's going to require an ID, a host, and the port. So here is where we'll need to figure out which ports they're running on. There should be some information in here. Start LN2. Uh, 58454 and 5894. So 58494 should be the port of L2. So we can say first we're going to need L2's pub key. So L2 CLI get info. Here the ID is that node's pub key. L1 CLI connect. Optional is just, well, ID is required. The other two are optional, but that probably won't work because that address is unknown on the Lightning Network so far. So I didn't test this out. It should be it's the pub key at localhost, and then that port, which was 58494. 58494. Connection refused. Let me try this. 7. Let's see. I know there's a way to get the ports that they're running on. I just don't remember the command, but let's see. We need to figure out what the RPC port is for Lightning D, but I don't think it's worth me trying to figure that out right now. So I will add it to the README after this, but for now, the nice thing about this startup reg test script is we can just do, I'm gonna have to stop this and start it again. Remember, we can do, I guess it's in the contrib script, contrib/, and then we can just run this connect command. Question in the chat, where is the README located? The README is this at our Plebdev's repository /developing CLN plugin /environment setup. I will see if I can do that. I'll try to add things to the chat on my end, but if you go to it's in our Discord, we linked to it, and it's in our GitHub at Plebdevs. So here we have this connect 1 to 2. So here actually this is what I could have done. L2 CLI get info. And I think here, yeah, see now we have 7272. This is what we should have been using to connect. So what we could maybe do is L1 CLI disconnect from that peer, and now L1 CLI list peers, none, L1 CLI connect to that peer at localhost 7272. ID should be a node ID. L2 CLI get info. Is this wrong? Oh, it's because this needs to be, so it's pub key at localhost :port. So now we can see L1 CLI list peers. So we have this one peer, but here, no channels. So the final thing that we're going to do in today's live stream is open up a channel. So fund channel is the command that we want. We need ID, and here you can see ID is the peer ID. That's their same thing as their pub key, and the amount. And the amount has some restrictions to it. I think this is the max Satoshis, unless you enable Wumbo channels. So we can try to do L1 CLI fund channel this ID, and amount is going to be amount in Satoshis. So let's say we wanted to send 100, 100 million, which is 1 Bitcoin, or we wanted to open a 1 Bitcoin channel. You can see the amount exceeded that maximum channel size. So I'm actually just going to use this to open basically the biggest channel that we can. So this is the transaction, and now this is broadcast to the mempool, but it hasn't been mined into a block yet. So I think if we want, we can see get mempool entry, get mempool info, get raw mempool. That might be the one we want. Get raw mempool. So you'll see here our mempool has one transaction. It's this one. So now if we do list peers, here now we have a channel. This is our one peer connected to him, connected true, and there's one channel here. It's in this state, awaiting the lock-in. You can see a little bit more here. Funding needs one more confirmation to be ready. So that just means we need it to get mined into a block. So we can use Bitcoin CLI, generate one, and now still needs one more confirmation. Usually I just end up generating, let's see what happens if we just generate. It takes a long time if we do a lot, so we'll do 15. I'm not sure what the all right, so we've mined enough blocks that now that channel open transaction is confirmed and the channel is ready for use. So let's see, we can list channels. Let's see, there's a little bit of information here. It looks like here we have 2 channels, even though we only opened 1. But you'll notice this is one channel, but this is the this is L2. So the source of this channel is L2. The destination is L1, and this one is reversed. And you'll notice L1 is the one that opened it, so that's this pub key. And here, let's see, where maybe it doesn't show us last update. Mount MSAT. So this is the size of the channel, but it looks like it doesn't show us how much we have. So if we do list funds, again, now this is just the one channel, and this is our UTXO. But you can see our amount MSAT is here, whereas if we did it with L2 CLI, then our amount MSAT is 0. So now L1 has funds on their side, but L2 has no funds on their side. So I actually don't know. We can do create invoice. So L2 CLI create invoice. I think maybe we can just do that. Missing invoice string. Inv string is of Bolt 11 form, but the final signature is ignored. Not actually sure what we're supposed to pass to create invoice. There's create invoice. We can key send destination and amount MSAT. That's going to be something to pay attention to, is whether it's MSAT or SATs, but everything in Lightning is millisatoshis. So the destination is going to be the hex encoded node ID, and then the amount is how many millisatoshis we want to send. So L1 CLI, and this is a sneak peek into plugins. Keysend is a plugin, and it's exposed as this RPC command. So we need to get this peer's ID, and we'll key send 1,000 sats. Payment looks like it completed. And so now L2 CLI list funds. Now we have this amount on our channel. So what we did for the last hour is we installed Bitcoin D using the snap package, and we built CLN from source. So now we have the Bitcoin CLI command, and we have the Lightning CLI command, which gets, if we, let's see, I think we can say, let me say alias L2 CLI. Yeah, so whenever we're running L2 CLI, what we're actually running is this script with the Lightning dir. The directory that we're using for this node is in temp/L2-regtest. And if we did the alias for L1 CLI, you'd see that it's targeting this L1 regtest. So if we just started Lightning D, maybe in mainnet, then we could also just run the Lightning CLI command. But these aliases are allowing us to run multiple nodes and have them accessible with these two aliases. So that's pretty much, I think, where we're going to stop it today. I'll try and add some of the stuff that we did at the end here into this README, and then what we're gonna be doing next time is mostly just going over here in the Core Lightning docs. There should be some docs on plugin development. So this could be some good reading if you're interested in getting a head start. And what we'll also probably do is automate. We might start by writing a script to automate all of what we just did, because sometimes it's nice to start with a fresh chain state when you're developing. Like fire up your computer and you start with this like kind of fresh, you have funds on the right side of all your channels, your nodes, your Bitcoin node has funds, but you don't want any of the old state from the last time you were developing. So it could be nice to just write a script where you could say something like /load env or something like that. And what this would do is start your Bitcoin node, start your Lightning node, and open them up in whatever channel configuration you wanted. But that's also the nice thing about this startup regtest script is we get sort of some of these commands that make it nice too. We might use some of these commands if we source this script, and then we can use these commands to write our own kind of custom setup for how do you want your nodes to all connect when you're developing. And so then we're going to talk about what a plugin is, and hopefully get to actually build a plugin and run it. And it could be what we'll be able to do is just like how we can run this keysend command. Once we build a plugin, we'll expose it as an RPC command, and we'll be able to run something like this, my plugin. Right now it's an unknown command, but once we build that plugin, then we should be good to go. So I'll stick around for a few more minutes if anyone wants to drop any questions in the chat. All right. If no one has any questions, then were you able to get into the Discord? Um, we're gonna publish this as a video, and we can put in the description the Discord, but it looks like you're able to get in, so cool. All right. Well, thanks everyone for watching. This is my first Plebdev workshop, so still ironing out a few things, but glad you guys enjoyed. And I'll see ya